In this video, we're going to learn about the difference between independent and dependent variables. So the independent variable is the one that sometimes changes by itself or the one that causes change in the dependent variable. So in my little diagram, that would be A. That would be the independent. It's the one that affects the other one. The dependent variable is the one that changes in response to the other variable. So sometimes in science you might actually call it the response variable. So in this case, B is a result of A, so B is the dependent variable. So for example, if you had a job and you were paid money based on how many hours you worked, then the independent variable would be the hours and the dependent variable would be the money. Because how much money you have depends on the number of hours you work. The number of hours you work doesn't depend on the money, it's the other way around. So how can we tell which is which? So let's say we were thinking about the cost of a basket full of apples. First, we need to identify what the variables are. Since we're talking about cost, one of the variables must be money. And since we're talking about apples, the other one must either be the number of apples or the weight of the apples. Usually it's by weight. So we're going to say it's money versus weight. So now we need to decide which one is dependent and which one is independent. The way I usually do this is I try it out, and often I'll even say it aloud. So I'm going to try it both ways. I'm going to say the money depends on the weight, or the weight depends on the money. So we got to think carefully about what's happening here. So in the first option, the amount of money that we have to pay is dependent on the weight of the apples. That feels right. You walk up to the checkout, they weigh the apples, they tell you you owe $4.73 because your apples weighed this amount of money. Or the weight depends on the money. What would that look like? Well, I guess that would be you walking up to the register and saying, I have $5. How many apples can I get? And then they would try and weigh out exactly $5 worth of apples. This seems less likely, okay? So sometimes they can go both ways. Sometimes both are possible, but usually there's one way that makes more sense. So the key here is that you're picking the way that makes more sense. That doesn't mean the other way could never work. It just means that you're picking the one that's most likely. So now that we've decided that, and I'm gonna erase the other option because we've decided that's not the case. Now that we know this, well, which one is the dependent variable? Well, we said that money depends on weight, so that means money is dependent, and weight is independent. Because the weight is going to be the thing that changes. You pick out more apples to put in your basket, right? You're changing the weight, and then the money is going to change according to the weight. The money is going to change based on the weight. Let's look at another example. This time, let's think about the height of a tree as years pass. I want you to pause, and I want you to try and decide which one is the independent variable and what is the dependent variable. To me, it makes sense that height depends on years rather than years depending on height, right? Time wouldn't change based on how tall you let the tree get, but the height of the tree would change as years went by. So that means that height would be our dependent variable and years would be our independent variable. All right, let's do one more. This time, let's say we're comparing the number of students in a class and the time it takes for the teacher to check the homework. Decide what's the independent variable, what's the dependent variable. right, so I think that the more students in class, the longer it takes to check the homework. So that would mean that the time depends on the students. So my dependent variable would be time, because time is going to change based on how many students are in the class. And independent would be number of students. Okay, so now let's look at another example. Let's say that a car is driving 60 miles per hour. Decide what the dependent and independent variables are here. So in this situation, the hours are going to be our independent variable, and the miles are going to be our dependent variable, because the distance that you have driven depends on how long you drove for. The time doesn't change in reflection on the miles. Okay, so the reason why we need to know this, the main one, is because it changes how we set up a graph. So you always put the independent variable on the x-axis, and you always put the dependent variable on the y-axis. So in this situation, you would have the independent variable, which is hours, on the x, and the dependent variable, which is miles, on the y. And you would still label your x and your y. And not everyone knows this, but there's actually also a relationship in how you set up the table. So if you were setting up a table, you would always put the independent variable on top and the dependent variable on the bottom. Or if you were doing an up and down graph, an up and down table, you would have the independent variable first and the dependent variable second. Now it's really important that you do it correctly for the graph, but the table is less important. Not everyone even knows that they're supposed to be set up that way. So it's super important that you do it correct for the graph, but for the table, not as important. And for our practice problem today, I want you to think about the outside temperature and the number of people at the beach. What's the dependent variable? What's the independent variable? And then I want you to write our short little sentence of blank depends on blank. Make sure to label which is independent, which is dependent.